This is Troy again. We're still talking about conversions, and now that we've got the principles down, we know those prefixes that we're going to be using from smallest to largest, bottom to top. We're ready to actually start doing some conversions. There's one other mnemonic device that I want to share with you before we actually do a conversion. We'll work through some examples here. That mnemonic device is very simple. It says, a gardener saying, let ugly roses die. If it's a pretty rose, you want to pick it, you want to give it to your girlfriend. If it's an ugly rose, go ahead and let it die. Just leave it there. Now, what does this represent? Well, this helps us remember how it is we're going to use those decimal places in that chart of those prefixes. And that is left up, right down. Left up, right down. So anytime I move the decimal point to the left, I'm going up my scale of metric prefixes. Anytime I move my decimal point to the right, I'm moving down the list of metric prefixes. And so this helps me correlate how that decimal point is moving and where I'm going with those metric prefixes that I need to be working with. Let's look at a couple of examples of how this is going to work. First of all, I've got this problem where they've given me, I've got 55,000 microamps, and I need to know how many milliamps this is. Well, I'm going to lay here my list so that we can refer to it. And what they have given me is microamps. That's here. They want to know the result in milliamps, which is here. If I am moving up the scale, then I need to move my decimal point to the left. So the decimal point is implied as being at the end of the number. If you don't have a decimal point, it comes at the end. And what I know is that to go from micro to milli, I need to move the decimal point to the left. Left, up, right, down. So I'm going to move the decimal point to the left. How far? I always move it 3 places. And so what I'm going to get is 55 milliamps. That's all there is to doing the conversion. I went from a smaller unit of measure to a larger unit of measure, and that means that the number needs to be smaller. I moved up, so I moved the decimal point to the left. We can do the same thing with this next example. They've given me 1,500 kilowatts. They want to know how many megawatts that is. Well, if I look at my list, I've got everything listed from smallest to largest, bottom to top. If I'm moving from kilowatts to megawatts, I'm moving up the list, and moving up tells me move the decimal place to the left. How far? Always 3 units. So I'm going to move the decimal point from where it is here, 3 units to the left, and that's going to give me 1.5 megawatts. So I've done the conversion from kilowatts to megawatts. I used my list as my reference. I moved up the list in units, so I moved the decimal point to the left. The last example they've given me is 1.5 million milliamps. They want to know how many kiloamps that is. Okay, so when I look at my units here, I'm going from milliamps to kiloamps. I'm moving up the list, but notice I'm moving 2 places up the list. The first time I'm going to go from milliamps to amps. That's where I don't have a metric prefix. And then I need to go again from amps to kiloamps. So I'm going to move 2 places on my chart. That means I need to move the decimal, and since I'm moving up, I'm going to move that decimal point to the left, but I need to do that twice. To go 2 places up, I need to move the decimal point 2 places left, and every time I move it, it goes 3 places. So I end up with 1.5 kiloamps. Using that chart, making sure that you have those in order from smallest to largest, bottom to top, and then remember to let let ugly roses die. If you can remember that, left up, right down. That will help you to get those conversions going in the right direction. Okay, a couple more examples that we want to look at here. And here we're asked to express in correct engineering notation. Now, we've talked about the metric prefixes. I haven't really said anything about engineering notation yet. And engineering notation is really simple. It's going to use those metric prefixes, whether you have kilo or mega or giga or tera or whatever it is. But here's the rule whenever we are working in engineering notation. How do I know if something is in correct notation when I'm doing this? Well, in engineering notation, what I want is 1, 2, or 3 digits to the left of the decimal point. I can have 1 through 3 digits left of the decimal. So if I look at here's some bad examples. These are not incorrect engineering notation. For example, if I have 1500 kilowatts, that is not incorrect engineering notation. How do I know? Because the decimal point is implied to be right here. I've got 4 digits to the left of the decimal. That's not correct engineering notation. Okay? In the same way, suppose I had 0.48 amps. Is that incorrect engineering notation? No, it's not. And the reason is because to the left of the decimal, yeah, I've got a 0 there, but that's just a placeholder. All of my values are to the right of the decimal. I need at least one value to the left of the decimal point for it to be in correct engineering notation. So these are not in correct engineering notation. They don't have the right number of digits to the left of the decimal point. When I'm looking at correct engineering notation, what that means is I have at least one, possibly as many as 3 digits that are going to be to the left of the decimal. So it could be like 1.5 megawatts. Here I have 1 digit to the left of the decimal point. That's correct. And I just did my conversion here. The same thing here. If I have 0.48 amps, that would be the same as 480 milliamps. And again, I did my conversion. Remember, you've got to move that decimal point 3 places. So if I'm going to move it 3 places to the right, I've got to get that 0 stuck in there so that the decimal falls where it needs to. And that took me from amps to milliamps. This is incorrect engineering notation because I have between 1 and 3 digits to the left of the decimal point. So when we see a problem like these next 3 that we're looking at, they're asking me to express it in correct engineering notation. So in this first one, they've given me 2,500 watts. They haven't told me what unit to express it in. I need to figure out what unit to express it in so that it's going to be in correct engineering notation. So what I find here is that if I've got 2,500 watts, that gives me 4 digits to the left of the decimal. That's too many. I need to move that decimal point, and if I move it 3 places there, that's going to give me 2.5. That's the kind of number that I want. I've only got 1 digit left of the decimal. Now, what kind of watts are those going to be? I moved left on the decimal point, and remember, let ugly roses die. Left means move up. So I went from watts, moving up, and that's going to give me kilowatts. So I've changed 2,500 watts to 2.5 kilowatts. That gives me a conversion and puts it in correct engineering notation. The second example gives me 0.9 watts. I need to express this in correct engineering notation. I don't have a value left of the decimal. I need between 1 and 3 digits over there. So I'm going to need to move that decimal point to the right so that I get some digits on the left side of it. Remember that I've always got to move it 3 places, so that means that 9, I'm going to have to add a couple of zeros to that to get that decimal where I need it to be. And now I'm moving to the right, let ugly roses die, right down. So I went from watts, and if I go down, that puts me at milliwatts. So 0.9 watts, the same as 900 milliwatts, and that gets it converted to correct engineering notation. The last example we have here is a little bit trickier, but still doable. Same principle, we're going to be doing the exact same thing. What they've given me is 0 point, a whole bunch of zeros, and 16 amps. I need to figure out what that is in correct engineering notation so that we don't have to read all those decimal points. Well, I need some of these significant digits on the left side of the decimal. So I'm going to need to move that decimal point to the right. Let's see how far I need to move it. I'm always moving it 3 places at a time. So if I move it here, well, that doesn't give me anything but zeros to the left. If I move it again, nothing but zeros to the left. If I move it again, nothing but zeros to the left. I'm going to have to move it again before I get some significant digits on the left side of the decimal point. So moving it in groups of 3, I end up with 16. Now, how far did I move it? I moved it 1, 2, 3, 4 times. Let ugly roses die. I'm moving to the right. I'm going to go down my list 4 times. I was at amps. That takes me to milli, micro, nano, pico. 16 picoamps is where I end up. That puts it in the correct engineering notation. I'm always looking to have between 1 and 3 decimals, 1 to 3 digits to the left of the decimal point, and then put the correct metric prefix in front of it. Anytime you're doing your conversions, remember those values from pico to nano to micro to milli to units to kilo to mega to giga to tera, bottom to top, low to high, and remember to let ugly roses die. That will enable you to do all these conversions that you need to get the numbers in correct engineering notation so that you can use them easily.